Okay, so let's dive into the numbers we're going to be working with this year. You've seen these numbers before, but you probably haven't understood what they're called. Each number has its own classification. There's specific types, just like you all are specific types of students. Some of you are seventh graders, some of you are eighth graders, some of you are athletes, some of you are musicians. You have a specific role. So do these numbers. So we are going to work with real numbers. What exactly are real numbers? Well, it's the set of all numbers that contain rational and irrational numbers. So real numbers are all numbers we work with in pre-algebra and that you'll also work with in Algebra 1. Any number we're going to be dealing with now are called real numbers. So whenever you're asked to classify the categories they fall under, they'll always fall under real. You will, in Algebra 2, learn something called imaginary numbers, but you will not see any imaginary numbers this year. So let's classify each type. We said real numbers are rational and irrational, and I emphasize irrational. You'll hear some teachers say irrational. I like to say irrational, even though it's an I, so that you understand the difference. So what are irrational numbers? Well, they're decimals that never terminate, meaning they go on forever and they have no repetition. So like 0.12678912743, and they're going to keep going on. Well, there's one very famous one that most people know. Okay, so most of you know pi. Well, the other ones that fall under this category are non-perfect roots. Okay, so if you take a look here, the square root of 3, that's how we read it, or pi, then the square root of 15. Now, if you look, there's 3 pi. The reason why this is irrational is because you still have pi in it. You're multiplying by pi. So no matter what, it's just going to be a bigger pi. It's still irrational. Now, rational numbers, there's a lot more to those. So that's what we're going to focus on now. A rational number, the way I tell students, and you might want to write this down, a rational number is basically anything that can be written as a fraction. That's it. So if it's a fraction, it's rational. Okay. Now, b cannot be 0. That's something we're going to get to all year. You can't have 0 in your denominator. But rational numbers, so anytime you see a fraction, make it rational. But it's also decimals that terminate, meaning decimals that come to an end or repeat. So some examples are 5/7, that's a fraction. 3. 3 is not a fraction and it's not a decimal, but I can make it a fraction by putting it over 1, so it's rational. Remember, go back up the top and underline and highlight all fractions or numbers that can be written as a fraction. -1, I can write that as a fraction. 0, I can put 0 1. 0 can be on the top. 20/5, which some of you might be saying, but that's 4. That's fine. You're right. 20 divided by 5, because a fraction bar means divide, is 4, but it can still be a fraction. Square root of 16. So here's a little different. When we did our rational numbers, we had the square root of 3. I can't take the square root of 3 without a calculator. I can take the square root of 16. It's 4. Here's a repeating decimal. 0.1212. That dot, dot, dot means it continues. Okay, so natural numbers. Why am I starting down there? Those are the numbers you started learning in elementary school. Okay, it's what we use to count. It's our counting numbers. 1, 2, 3, 4, 5, and so on. No decimals, no fractions right there. A natural number is our counting numbers when we use to count how many crayons you have or how many dogs there are. Now keep in mind, I can make those fractions. That's why they're rational. So whole numbers are all of our natural numbers, so our counting numbers, as well as 0. So the only thing that changes there is 0. 0 gets classified as a whole number. Then you have integers. The definition of integers are all whole numbers and their opposites. So therefore, -2, 4, -18, 9. Okay, so pause right now if you need to get something written down because it's very important. You might also want to rewind and add in anything that I said that's not written, because we're going to go show you how this system works. So we organize our real numbers normally by something like this. Sometimes you'll see a square. But the irrational numbers sit out by itself. They have their own circle. They're in their own category. Remember, we said it's like a square root of 3. Then we start in the simplest form. It starts with a natural number. 1, 2, 3, 4, 5. Well, if it's a natural, so if it's classified as that, it would also be a whole number. So we'd put it in the natural. What's the only whole number that's not natural? 0. So what I would do is I would write a 0 in that whole number circle. Then we have our integers. So there are some that would fall in that integer circle, but not in that whole number circle. What would be an example? Right, like a -4. You couldn't put that in the whole number circle. It'd have to go in the integers. And then last is rational. The whole big circle is rational. So what would go in there? 0.5, 1/4. Those are not in the other circles, but they're in the big rational. Okay? So let's go name all sets to which each number belongs. So -47, you got to be careful. What does that fall under? Well, it's a negative, so it's, okay. I'm going to have these on the side so you know what we're dealing with. So it's a negative, so that means it's an integer, but it's also something else. If it's an integer, it is rational. So you need to understand that. So go look at number 2. Right away, I see something there. It's a fraction. There's only one area that could fall under, and that's rational. It can't go under anything else. This says the absolute value of -9, meaning it's a natural number because the absolute value of -9 is 9. That's a counting number. If it's a natural, it's also a whole. If it's a whole, it's also an integer. And if it's all 3 of those, okay, then it's also a rational. Okay? Remember, all of these are real numbers, so I'm not going to write that every single time. You can if you want to. Let's go look at number 4. Square root of 23. Now, think about this. We talked about this yesterday. A perfect root. This is not a perfect root. It's not one of the ones we have to memorize. I can't find it without a calculator. Therefore, it is irrational. It's not perfect. Now I have 1.5625. Okay, that's a decimal. It terminates, it ends. So therefore it's rational, and that's the only category it can really go under. Then I have 0. Remember, 0 is that special one that changed. That's right, that makes this a whole number, but not natural. An integer. 0 is its own opposite. And then of course, sorry, that should say, change that, ladies and gentlemen. That was just a copy typo. This should be, it's not natural, it's rational. Okay? So here's what I want you to do. Pause the video and try these on your own. When you submit your notes, I'm looking to see these 4 done and tried. That's all I ask for. Pause now. Okay, so I'm going to start this off for you, and then you're going to finish it off. You're going to place the letter of what's in your values column into the smallest set that it belongs. So here's what that means. Let's look at A. Well, that's a negative square root of 50, but it's the square root of 50, meaning it's not perfect. Therefore, it's irrational. That's where it belongs. That's the only place it can go. Let's look at B. B is 3.895. Well, that's not a natural number. That's not a whole number, and it's not an integer. So it has to go out here in this little arch. Let's look at 8. 8 is the letter C. That's a counting number. When I used to count how many things I had. So if it's a counting, it's a whole number. It's also an integer. So it's all of them. So how do I know where to put it? Well, I'm going to put it in the circle that's in all of them. That part would be all of them. So what I want you to do is I want you to finish the rest of these to the best of your ability. There's going to be some you probably don't know, and that is okay. But I'm also looking for the rest of these letters filled in for you to get full credit on your homework tonight. So don't forget to be studying your perfect roots. You need to understand all this material, okay? You really need to be able to classify. You need to know what is a perfect root in order to be able to decide if it's rational or irrational. Be sure to go load your notes to Teams and feel free to re-watch the video if you need to.